Hey guys, this is Coach Tapman. We're going to be talking about forces and kind of what they are and how we can break them down and take advantage of them whenever it comes to design and optimization, stuff like that. So first, what is a force? Well, according to a wonderful website I recommend you guys check out, it's called the Physics Classroom. A force is a push or pull upon an object resulting from the object's interaction with another object. And so I love that word interaction in this. Forces really come from two objects or existing uh, things in the universe. Maybe it's electricity, maybe it's an electron if you consider those objects. It's two objects interacting. And so it can really be a huge, massive, large-scale object or a really small one. And that's kind of, those are two different kinds of science that we're talking about, relativity and quantum theory, stuff like that, but it's all the same. A force is the interaction between them. So if we just recall from Newton's laws of motion, they all have to do with forces. So what we learn is that forces and motion are very interrelated when it comes to physics. And so especially the second law, we're going to be using that a lot as we continue talking about forces and how we can consider forces in designing a machine. So again, types of forces. There are four fundamental forces that are generally agreed on and discussed whenever you're talking about forces. There's gravitational forces, so that's the force of gravity coming from every single atom that's existing in the entire universe and how they attract and draw one another to one another. There's electromagnetic that comes from electricity and magnetism, the electromagnetic fields, forces created just by the existence of charged particles. There are strong forces, and so strong forces usually refer to strong intramolecular forces. So those are the forces holding an atom together. So those are actually between the quarks and the inside the subatomic particles that make up protons, electrons, neutrons, stuff like that. But a strong force is considered something like the force that's holding together the nucleus of an atom. And then there are weak forces, and weak forces really are the forces that exist between different molecules. So that's the intermolecular forces. And so that's between separate atoms, and so really that covers a ton of different things. If you think about pushing against a wall, well, what's really happening is the atoms in your hand are pushing against the atoms making up the wall. They're composing the wall, and the atoms in the wall are pushing back against your hand. And so even though you're applying a force on that wall, the force of the atoms themselves, it's as if the wall atoms are saying, no, we're not, you can't just move through here. We're currently existing in this position, so you can't just move through us. And so the atoms in your hand and the atoms in the wall are pushing against each other. That would be an example of a weak force or a weak intermolecular force. So if you look at these contact forces, there's, you can consider contact forces and non-contact forces. For examples, I found this online at the link below, but if you consider these contact forces, really all of these contact forces are weak intermolecular forces because they are the forces are derived from atoms bumping into each other and not being able to pass through, not being able to change the nucleus of the other atom. And so they create resistances, and that's your contact forces. Non-contact forces alternatively include things like the magnetic forces, so forces from magnetism, and electric forces, forces from electrically charged particles, and gravitational forces. So they're not actually touching, but they still generate forces. Typically, electromagnetic and strong forces are considered to be the stronger of these four fundamental forces, and gravitational and weak forces are considered to be rather weak in comparison. So let's think about Newton's second law, because it's really important. It's a really, really important law to a lot of the equations that we derive for different fields of physics. It's incredibly fundamental. F equals ma is your forces equal to your mass times your acceleration. And this comes straight from Newton's second law. This is really important to a lot of different fields, and you can read these fields below if you want to, and you can go online and look at different branches of physics, and you'll really see this equation come back time and time again. Another thing to consider that's really important for forces is that they have different components. They have direction and magnitude, right? And so if you are in a jet engine, if you're in an airplane, well, if you're in a jet engine, you're in bad shape. But if you're in an airplane that has a jet engine attached to it, and somebody turns the jet engine on, the force that that jet engine produces, it's going to be pushing air out the back of the jet engine, and so it's going to be pushing forward in the forward direction of that jet engine. And so if the airplane is attached to it, if the airplane is attached to that jet engine that's pushing all that air out, the jet engine itself is going to be pushing the airplane forward. And so you know the direction that is forward. That's important because if the jet engine was turned the opposite direction, your airplane wouldn't be flying. You would be crashing while, incredibly and very uniquely, you would still be crashing, which you don't want in an airplane. And so that the direction is really important to understanding a force. Magnitude, similarly, is incredibly important. The harder you push on a box, the greater the magnitude of the force that you apply to the box. So if you have a toddler push on a box, maybe the toddler moves it. If you have a full-grown adult push on a box, the box is likely going to move if it's not got any crazy contents on the inside of it. If you have a bulldozer push the box, there are very few boxes that are not going to move from a bulldozer pushing on them. And so there is a magnitude associated with the force. That's why if you have two different people try to lift the same weights, the stronger person can lift it and the weaker person cannot. It's because they're able to produce a larger magnitude of force on that weight. And so all forces are composed of these directions and magnitudes, and that's really important for us to be able to work with forces and equations. Because they have a direction and a magnitude, we can consider them as a vector. And that's how forces are often drawn and shown in diagrams as a vector. And if you've seen Despicable Me, vector says, direction and magnitude, oh yeah. Well, that's really the way that we like to depict forces because it helps us understand them visually. And so if you see here, you have this man pushing on a box and he's producing a force. And in our case, we just made the directions arbitrary. We just said, oh, well, the direction is x and y. The direction in the same direction as the force is x and perpendicular to that is y. And that's how a lot of the time you work with forces is you set up an arbitrary or some reference plane for you to make the calculations. But it's important for you to understand that forces exist in a direction of some reference plane that you have to decide on when you're solving these equations. And so let's talk about force decomposition. We're looking at this black F vector here, so our force vector, and we're just putting some arbitrary x and y plane in it as well. Or let's say it exists in some arbitrary x and y plane. And this force is at some angle theta to the x axis. So you have some force at some angle theta. Well, how is it that you're going to solve for how could you simplify this so you could add several forces together? Well, you could use force decomposition. Instead of just having some force at some angle, you can break this into a force in the x direction and a force in the y direction. So that way, if you had multiple forces at at all different angles, you can decompose them into like directioned forces, and then you can add those together to make your life easier. So in our scenario, we just have a two-dimensional plane. You can solve for the forces in the x direction and the forces in the y direction using some simple trigonometry. So we're going to do some practice breaking down these forces. So assuming that you have a force of 50 newtons and an angle of 30 degrees for theta, and this isn't entirely correct. That technically that should be the magnitude of the force vector is equal to 50 newtons, but let's assume that's what we're given. We're going to go ahead and break down the following force vector into its components. So I'm going to give you guys a couple moments here. You can pause the video and go ahead and try to solve for the x portion of the force vector and the y portion of the force vector, or the x component and the y component. And so go ahead and pause the video and give that a try. Okay, by now I'm assuming you've been able to solve the problem or give it your best stabs. Let's go ahead and look at the solution. See, there's that magnitude. Solving for the magnitude of the x component of our force vector, we were able to solve using 50 times cosine of theta, or 30, And we solve for that equal to 43 newtons. It's actually about 43.3, but just to keep sig figs here. And similarly, for the y component, we were able to solve for it as 25 newtons. And so again, this is really useful because not only does this give us something that's a little bit easier to use just along the x and y axis, intuitively it's easier to visualize, but also now if we have multiple force vectors, we can add those different vectors together by adding their x and y components together. So that way we're able to get a resultant force in the x and y direction. And if we want to, then we can use that in trigonometry to solve for some angle of a resultant force magnitude. And so this is a general introduction to forces, and I hope this is useful. Please leave any comments if you have any questions, and I look forward to seeing you guys in the next video. Thanks. Bye-bye.